Today's modern aircraft are not only extremely expensive, but also quite complicated to maintain. Maintenance and logistical experts, often professionals with decades of experience, are still challenged with troubleshooting faults that affect numerous onboard systems differently. The performance of a modern aircraft requirements officer, class desk, wing commodore and maintenance officer, and even squadron commanding officers, maintenance officers, MMCOs, and MMCPOs can be greatly improved with the implementation of modern technology that simply takes advantage of current information and data that these systems already provide. Aircraft readiness can be significantly enhanced not by building an entirely new system, but rather with a cloud-based tool or software that can be implemented into current programs of record. Imagine, if you will, a tool that takes advantage of the latest technology, armed with a database that holds the entire body of aircraft system alerts, cautions, warnings, and applicable maintenance action forms that not only helps troubleshoot current faults, but actually predicts with a high degree of accuracy when aircraft components will fail in the future. This tool is currently being developed as machine learning and advanced analytics for aviation sustainment, NAVAIR's SBIR N191 TAC 007. Hello, my name is Captain Miguel Pecco, United States Navy retired, and I'm a Senior Program Manager for Mosaic ATM. In my duties as a Mosaic Program Manager, bringing over 30 years of active duty naval service, 3,000 hours of flight time, and over 730 aircraft carrier traps in the E-2D Hawkeye to a team of brilliant data scientists and software engineers, I will be presenting you with an overview of a software tool that will serve as a true sustainment force multiplier for the Navy in the form of artificial intelligence and machine learning technology. Of note, this technology can be easily utilized for any complicated machinery such as advanced aircraft, both civilian and military, and any other industry that uses modern machinery. The name listed on the slide, Captain Jim Gardner, United States Navy retired, is that of my colleague who can also help answer any of your questions, but I have just recently taken over as the lead program manager for this effort. This Tech Talk is on utilization of machine learning and advanced analytics for the design and development of improved maintenance procedures by fully exploiting the E-2D Advanced Hawkeye's automated logistics environment. During this era of great power competition, military readiness, the ability of our forces to fight and win today, is directly dependent on the tools that our warfighters use to deter and, if necessary, defeat potential adversaries around the world. Sustainment, and specifically maintenance and logistics, of modern aircraft are critical to overall Navy readiness. Following an E-2D Advanced Hawkeye sortie, maintenance personnel currently can review flight data using an onboard data retrieval system called the Automated Logistics Environment, or ALE. Utilizing the E-2D's ALE viewing tool, maintainers are assisted in identifying necessary maintenance actions. Unfortunately, the ALE is more of a receive and display system lacking a deeper analytical capability. Aggregated data from sorties over the entire life of an aircraft, including every aircraft in the E-2D wing, is currently underutilized and essentially wasted over time. This is a missed opportunity that results in reduced aircraft availability and readiness. To address this shortfall, the Navy asked Mosaic ATM to design, test, and implement an ALE analytics application, think software tool, utilizing all E-2D historical data, information from every flight that every E-2D Advanced Hawkeye ever took, to help troubleshoot faults and even predict catastrophic component failures that would have previously rendered aircraft not mission capable. With an intuitive user interface, the ALE Analytics application tool will provide aircraft component failure predictions, improve maintenance diagnostics, and allow a refinement of Hawkeye community component inventory policies. Through predictive modeling that utilizes advanced machine learning and data mining technology, Mosaic ATM's data analytics application tool will improve the Navy's ability to provide fully mission-capable E-2D Advanced Hawkeyes able to conduct airborne command and control missions in support of operational commanders. This analytics tool will be both adaptable and scalable by use by any type model series aircraft in both military and commercial applications. Additionally, this technology can easily be adapted for the automotive industry, construction industry, or any industry that utilizes vehicles. Formed in 2004 during the 100th year of powered flight, Mosaic ATM is a small company headquartered in Leesburg, Virginia, with a complement of around 100 staff. We bring our corporate values to bear: scientific rigor, creativity, and collaboration in solving the most complex problems, no matter the industry or customer. We are proud of our culture of innovation and continual improvement focused on meeting customer needs. Whether improving the capacity, efficiency, safety, security, and sustainability of air transportation, assisting commercial organizations, or applying machine learning and artificial intelligence to supporting DoD missions, Mosaic is on task every day. Mosaic ATM scientists, engineers, and subject matter experts, many recognized leaders in their respective industries, combine operational knowledge of the National Airspace System with cutting-edge computer science skills, operations research, systems engineering, human factors, and program management. With a proven track record of working with such partners as NASA, the NGA, the FAA, the DoD, Caterpillar, various commercial airlines, and many others, Mosaic provides advanced analytics and engineering services to research, development, and deploy decision support and automation systems for complex business operations. As a matrix company with both government and commercial business units, our three core competencies include Mosaic ATM, which focuses on R&D, engineering services, and commercial aviation solutions. Making complex artificial and machine learning solutions actionable, explainable, and usable to any organization, Mosaic Data Science focuses on a unique blend of data engineering, statistical analysis, business problem solving, and technical deployment services. Made up of software developers and engineers, data scientists, and product development teams, Mosaic Software offers technical and business expertise to convert your strategies into software systems that optimize your business performance. Utilizing professionals from our various business units, Mosaic ATM is comprised of highly qualified experts in their fields, uniquely skilled in their disciplines. Additionally, armed with cross-disciplinary aptitudes, Mosaic ATM staff are perfectly suited to help any business or entity reach their fullest potential. One of the advantages of working with Mosaic is that we have an inherent ability to take data that your current systems already provides, and through state-of-the-art application of artificial intelligence, machine learning, and deep learning, we can help any company address the most complex of issues. And note that no new system or widget is required to be built. Mosaic provides significant value simply using the data and information that your system already provides but is currently underutilized. Northrop Grumman's E-2D Advanced Hawkeye is a game changer in how the Navy conducts airborne battle management and command and control. With a 2-generation leap in radar sensor capability and a robust network-enabled capability, the Advanced Hawkeye delivers critical, actionable data to other aircraft and C2 entities conducting missions in support of national objectives. These advances provide warfighters, to include those of key American allies and partners, with the necessary situational awareness to compress the time between initial awareness and active engagement. Initially focusing on NAVAIR PMA 231, the U.S. Navy asked Mosaic ATM to develop a tool set that would leverage machine learning and analytics to analyze the system with automatic logistic environment data collected across the Advanced Hawkeye fleet to design and develop improved maintenance procedures with the goal of improving overall readiness. Working with the PMA 231 integrated product teams, Mosaic is analyzing ALE flight packages for upfront metrics of critical aircraft components and display system cumulative flight built-in test trending, performing data mining to assist maintenance troubleshooting by analyzing in-flight performance monitoring, advisory, caution, and warning information, bit code flight data, and applicable maintenance action forms. Mosaic is developing a prototype software toolset capable of machine learning, data mining, and identifying trends to improve maintenance procedures and readiness. A Mosaic strength, our team is adhering to agnostic, non-proprietary, interoperable, and best industry development processes and technologies to ensure seamless integration of the analytics application toolset. Per the National Defense Strategy, the entire DoD has been challenged to optimize readiness. The naval aviation enterprise needs to optimize aviation sustainment for maximum fleet readiness through advanced machine learning analytic solutions for predictive and performance-based maintenance. Creating a high-end predictive analytics tool for the E-2D Advanced Hawkeye, utilizing Naval Aviation Logistics Command Management Information System, maintenance action forms, and ALE in-flight performance monitoring ACAUS data, Mosaic's analytics application tool will be perfectly positioned to transition these algorithms into additional NAVAIR programs. The standardization of the NAVCOMAS maintenance data format would make every NAVAIR aircraft, both Navy and Marine Corps, perfectly suited for this new capability. The transition to Air Force or commercial aviation stakeholders is quite feasible. The Advanced Hawkeye's current ALE functions as a receive and display system for one flight at a time, and simple displays consist of time series single sensor graphs. With Mosaic's analytics application solution, analysis of NAVCOMAS and ALE data will predict and report future component failures and provide interaction and graphic display of trends over multiple components, flights, and aircraft. The Automated Logistics Environment Analytics Application Tool can be thought of as predictive maintenance microservices, or more generally understood as pipelines, that will directly support the Program Office integrated product teams, the Advanced Hawkeye Wing, and Fleet Squadrons. Today, flight package data is offloaded from an aircraft during post-flight maintenance as depicted on the left side of this diagram. Single flight data is currently depicted as standalone information with no further analysis being done. But applying Mosaic's machine learning algorithms and data analysis techniques to previously archived uploads, users will be provided with model updates that can be used to make key maintenance and sustainment decisions to optimize aircraft readiness and fully mission-capable rates. Accurate predictions of component failures for leading condition-based maintenance will reduce troubleshooting times due to quicker and more accurate diagnostics. Armed with an intuitive, user-friendly human-computer interface, Hawkeye community leaders will have the knowledge and confidence to more accurately refine component inventory policies, make future purchase decisions, and determine when systems should be further updated or modified with respect to reliability. Early development of the ALE analytics application focused on integration of descriptive and diagnostic algorithms using only ALE flight package data, providing basic visualizations for manual trend analysis. Using Amazon Web Services, a complete repository of all E-2D maps from NAVCOMAS have been integrated into modeling. A data preparation pipeline that is scalable, cost-efficient, reproducible, and automated is now in place to enable ingesting additional flight packages for any size data required. Model building workflow is in place to enable modeling FMC aircraft and real-time inference as depicted in the figure. Currently in the Phase 2 base contract, Mosaic data scientists are still developing ALE AA 0.1 beta prototype, milestone 2, to be followed by a beta in-test environment later this year. With continued success, Mosaic anticipates development of ALE AA 1.x prototype at the end of fiscal year 2023, fully ready for the live deployment of ALE AA 1.0 seminal transition event. Consider a future in which the Hawkeye community can integrate maintenance action data with in-flight performance monitoring. Today, individuals must cognitively merge two separate sets of data and attempt to discover trends and connections regarding the complicated E-2D Advanced Hawkeye with all its components, systems, and subsystems. But with Mosaic's ALE analytics application tool, analysis of historical maintenance actions with in-flight performance monitoring data will be conducted with a more complete picture of aircraft performance. A new intuitive dashboard display will provide better context for fleet customers as high as the program office down to the fleet squadrons, thereby increasing understanding of supply chain and predictive maintenance opportunities. Advanced analytics for descriptive, diagnostic, predictive, and prescriptive solutions will capture complete understanding of the current and future state of the aircraft, identifying opportunities to repair failing components before they reduce aircraft readiness. Visualizations for multiple components performance over multiple flights and multiple aircraft allows both manual and machine learning assisted analysis of individual components, aircraft, and squadrons. Modern dashboards will allow a more complete interface and understanding of what data analytics provides. Currently at technology readiness level 5 or 6, Mosaic has received initial ALE flight package sets for analytics application development. By the end of this fiscal year, we will be at TRL 6 or 7 with a deployable ALE AA 0.1 beta in test environment. Phase 2 option year 1 will bring a deployable ALE AA 1.0 for an at-sea test event with a Fleet Advanced Hawkeye Squadron and TRL 8. The commercialization plan will initially focus on other NAVAIR program offices, but quickly expand to U.S. Air Force squadrons and commercial end users such as UPS, FedEx, United, Delta, and Hawaiian Airlines, to name a few. Mosaic's business model, initially focused on algorithm development using legacy NAVCOMAS and ALE data repositories of historical data, will provide predictive maintenance microservices for E-2D logistics and maintenance efforts. Addressable market is in excess of $15 million in license fees and sales with an internal R&D budget of $500,000 over the next 3 years. Mosaic already has a direct path to commercialize through enhancing existing consulting services and machine learning product development for several commercial airlines, and the real potential to break into the automotive industry, construction, or any industry utilizing vehicles that would benefit from this technology development. When Mosaic's work proves successful with E-2D NAVCOMAS ALE integration, future development includes NAVCOMAS and IFPM data from other NAVAIR platforms such as the F-35, F-A-18, EA-18, P-8, MQ-4, MQ-25, and SH-60 to facilitate next-generation maintenance. Mosaic would like to team with partners that desire affordable solutions for enhanced aircraft maintenance and logistics. We can augment any NAVAIR stakeholder through a partnership with a government program office or industry prime combat system integrator, and would be able to adopt our algorithms as soon as we receive access to NAVCOMAS MAF data. Mosaic is poised to provide high-end data stream analytics capable of wading through an exponential increase in collected data, supplementing finite human analyst resources, and increasing aircraft readiness. Again, my colleague's name is listed on this slide, but I am happy to speak to anyone interested in this exciting application of new technology. My name is Miguel Pecco. My email address is mpeko@mosaicatm.com. My number is 757-618-3306. Please contact me for any questions. By utilizing the latest techniques in artificial intelligence, machine learning, and deep learning, Mosaic ATM can take data that already exists and assist any customer or team address complex problems. Send me an email or give me a call, and let's talk about how Mosaic ATM can help ensure America's military overmatch is maintained and even extended during this era of great power competition. Thank you.